In this video, we'll be talking about TLS and SSL protocol. TLS means Transport Layer Security, and in this protocol, it ensures the secure communication over computer networks. So, to know about TLS, we should know about secure socket layers. These secure socket layers introduced many cryptographic and security concepts, and as SSL had some vulnerabilities, it was modified and developed, and now it is being used as TLS. So, some key features of TLS are encryption, data integrity, authentication, forward secrecy, and versions. TLS had multiple versions including the TLS 1.2, 1.2, 1.3, and now we are having the most secure version which is available. And now I am going to show you how to capture some TLS packet in Wireshark. So first let's open Wireshark, and then we have to select the network we prefer to choose. So now the Wireshark starts to capture all packets which has been running in the internet. And to capture a TLS packet, we have to take a website which has a login page. For example, in this Flipkart, we have taken the login page, and one important thing to be noted: HTTPS, this secure layer HTTPS means TLS is being applied over here. When TLS is applied, we can see that TLS packets will be captured over here. So now we can stop this and check for T. So now TLS packets are being captured. In TLS, we have client hello, which is our system has sent a request to the server, which is the server is here is Flipkart, and that's the client hello. And then we will get the server hello. Server hello is server accepts the client's security connections, and then we have created a new connection. Now we have a server key exchange. Server exchange the key to have a secure connection. That's the server key exchange. And then there is a cipher key. Cipher ensures the security in TLS packets. So then application data. In application data, the application data protocol is being used to transfer the application from our client to the server. So this is TLS.
So, hello everyone. I'm here to tell about the SSL or TSL handshake. So, in that, first of all, I'm going to explain what the main terminologies that are required for a successful TSL handshake. In that, first, I'm going to talk about the cipher suite. A cipher suite is a collection of cryptographic algorithms used to establish a secure connection between the client and the server. During the SSL or TSL handshake, both the client and the host computer agree upon an encryption method from the cipher suites to create keys and encrypt information. The cipher suite contains digital signature algorithm has functions for checking if the data is transit, is modified, asymmetric encrypted, algorithms for handshake, and symmetric encryption algorithms to maintain session security. And the next thing we are going to talk about is the key exchange. TLS key exchange allows two parties to use a cryptographic algorithm by exchanging cryptographic keys. For example, a symmetric session key is generated during an SSL or TSL handshake before an encrypted message is transmitted. RSA and Diffie-Hellman-Merkle are the top key exchange algorithms used. So that in that uh, symmetric encryption encrypts and decrypts using the same key compared to the asymmetric cryptography. This is more efficient. It needs less encryption time, uses fewer resources, and can transfer large volumes of data, and while also maintaining confidentiality. Ciphertext is the same, also smaller than the plain text. Some of the examples of widely used symmetric encryption includes data encryption standards, triple data encryption standards, advanced encryption standards. And the next I'm going to say about is the asymmetric encryption. Asymmetric encryption uses two keys, a public key and private key. This means a message encrypted with the public key can be only decrypted with the corresponding private key. It provides better security as keys are never shared and allow the user to authenticate data using digital signatures. It is slower than basic semantic encryption and can only be utilized for a small amount of data. The ciphertext is the same or larger than plain text. Some of the examples of widely used Asymmetric encryption includes reverse Shamir Haldeman, digital signature algorithm, and data element explained. And the next one is authentication. Authentication is each party in a communication verify that the other party is who they say they are. SSL or TSN handshake verifies the server's credibility by combining its public key with the digital signature issued by the SSL certificate authority, ensuring a client can trust the server identity. So, let's see about the TSL or SSL handshake. In that, there are nearly nine steps. So first step is that the TSL or SSL client will send a server uh, a client hello message that details the client's configuration settings, including the SSL or TSL version. As Hypersource, it supports the data compression technique. It employs a string of random data, refer to it as client random. In step 2, the DSL or SSL server sends back the server hello message containing its public key, digital certificate, session identifier, the cryptographic algorithms, agreement selected by the server from the client supplied list of algorithms, and the server are random. In step 3, the client performs the authentication by contacting the server's certificate authority to validate the web server's digital certificate. This confirms the authenticity of the web server, thus establishing trust. In step 4, during the client step, the client extracts the public key from the verified certificate and generates a new random secret called pre-master secret. The pre-master secret is then encrypted using the extracted public key and sent to the server. In step 5, the SSL of the server decrypts the pre-master secret using its private key. Step 6, both the client and the server now use the pre-master secret to configure a shared secret. In step 7, the client sends an encrypted finished message using the shared secret key. This message says that the client's part of the handshake is complete. In step 8, finally, an encrypted finished message is sent back to the client from the server using the previously agreed shared secret key to indicate the end of the server side of the handshake. In step 9, once the TSL or SSL handshake and negotiation is done, the server and the client communication continues. That is, they begin to share files and messages using the key. So now I'm going to demonstrate how this works, and for that I'm taking Amazon page, and in that I'm going for the sign in page. So let's keep this open, and we just go to the my shop and filter SSL. So here you could see the packages received, and in that we could see the client from the message. And when we open, you could see the random and suits uh, that
Now we are going to see about an TLS handshake failure. For that we are taking an NS lookup magicball.net, which is an famous 90s game website. Using NS lookup command, we can get the DNS of the website. So we are putting an NS lookup command. After receiving the DNS of the websites, we are putting a curl command, which is an curl command is used for hosting the parameters of the website. After hosting the website, we are capturing a packet. Now you can see the message of the TLS message: client hello, server change, and application data, and all the messages of TLS message. Next, you need to recapture the filter for identifying the failures of the TLS handshake. For that, you are putting a command called magicball.net colon 80. Colon 80 is defined for a port number. 80 is a port number which is used for HTTP, which is an hypertext transmission protocol. So after putting the port number, you need to recapture the packets. We are going to packet capture. Before that, we can see that there is a wrong version number message, which is an which is which is a wrong version number. Next, you go to the Wireshark, you can see that there is a no TLS message in the packet capture. For that, we need to select any one of the packets of shown there. By right clicking, you can get you can get the port numbers and the current uh, protocol. You can select the value and change into 80 and the current into TLS failure. So instead of 61557, you can select 80 and current. For that, you are choosing the TLS failure. After clicking TLS, you just see the TLS messages in the packet. You can see all the TLS messages, TLS client allow, and these are the handshake failures in the TLS protocol. Thank you.
Hi all, now I'm going to explain about TLS or SSL data encryption and decryption. For this, first we have to create a system variable or a log file, that is an SSL key log file, which can be created with a command like type nul space and anglo braces space SSL key log dot log. So what I have to do now is we are going to advanced system settings. In advanced system settings, we have to change the environmental variables, or we have to set the environment variables. So for that, I have already set an environmental variable, that is SSL key log file. So it also has an variable value. This variable value has the log file that I have already created now. Okay, yeah. So finally, I have to give OK and OK, and again you have to know okay. Now that log file will capture all the logged values or SSL values or TSL values that has been transmitted through a network with the help of a browser like Firefox or Chrome, etc. So now today we'll use Firefox. So we have to go to open Firefox. Before this, what we have to do is we have to go to Wireshark. We have to run as administrator. So mm, I'm going to capture the Wi-Fi. I've started capturing the Wi-Fi. So what I have to do is we have to go to an in private window. uh, for example, we will go to some site like pluralsite.com. Yeah, so it says that the data is actually encrypted. It is very secure one. Okay, it is verified by Cloudflare. For more information, you can click over here. All these data, all these data can be analyzed with the help of Wireshark. So what we're going to do now is we have to close all these tabs, and we have to stop the capture over here. So I'm going to apply a filter that as frame contains the website name is plural site. So plural site. So we get all DNS. This is the domain name system. That is plural site C, plural site. Everything is plural site. So the first client hello. So let us trace the client hello with the help of a TCP packet. So it can follow TCP stream. Yeah, we have got this. Now we can find that the client hello, the first client hello is over here. We're going to analyze this packet. So double click over this. Transport layer security is what we're going to analyze. That is TLS security. So it is under an protocol, handshake protocol, that is a client hello. So what has happened is the client sent hello to the server with the help of version TLS 1.0. So what are the protocols? So it's a random number that has been random bytes that has been sent by the client to the server. So cipher suits. So there are n number of around 17 cipher suits. Out of these 17 cipher suits, one suit is matched or one suit is accepted by the server side. That might be any of these 17. So we'll check that from the server hello. So we could find the server name as plural site. Yeah, pluralsite.com. We could find the server name also over here. So we can find what are the algorithms or what are the signature algorithms has been over here, activated over here. The extensions and the record limit, everything is can be identified with help of this. Okay. Mm, the data is encrypted. The data is encrypted here. That's why we can't see any HTTP packet. HTTP packet, if there is an HTTP packet, it means the data is not encrypted. So after this client hello, we are having a server hello. It is on port 443 to port 58358. It's an acknowledgement that has been received from it. So the next is the server hello event. So on double clicking, if we could find what the server hello has done. Yeah, it's the same. So it is a server hello protocol. It's a handshake protocol. So I said we are going to match with some cipher suit, right? Yeah, we have matched CLS, ECDHE, RSA with AES and 128 GCA SHA 256. Yes. We could find what are the elliptical curve points and what are the formats and what are the algorithms being used over here. Next will be the certificate exchange. Yeah, we are having a certificate over here. So the certificates we could find what are we said that there are around 4 certificates that has been identified that's been recognized by Cloudflare. So the first one is a plural site, common certificate, that is plural site for the plural site. Who has given this authority? Who signed certificate? Everything can be viewed over here at this part. The next one is given by an Amazon RSA. This certificate. So we are around there are 4 certificates over here. The next one will be the server key exchange and server hello. On double clicking it, we could find what has happened over here. Server hello is done. So we are using SST256 as a signature hash algorithm and the transport layer security. Yeah, that's all. Oh, so we have to find the application data now. So to find the application data, we're double clicking the application data over here. We are just seeing that encrypted application data. We don't know what has been in this data. So to understand or to find out what is hidden in this data, we have to change the preferences. So we have to go to client key exchange. On right clicking it, we can find the protocol preferences. In that, we can go to transport layer security. Let open transport layer security preferences. We have to browse and upload the SSL log file that we have used now, or that we have created now. That will store those in documents, so I can find here. Yeah, SSL key log. It's a log file. On opening this log file and by clicking OK, we could find HTTP packets. So on the clicking now, opening this, we could find what has that encrypted message is finished. Nothing but the word finished. So there has been client hello followed by a server hello, certificate exchanges, so cipher suit exchanges. Then the protocol is finished. So we have decrypted or just we have ended with an hello or finished. That's all. That's what is then encrypted data. Yeah, this is just some random bytes that has been sent over to the server and the client. That's all. This is how we can find. These are the HTTP packets. That we always find some magic. It is encrypted version which also can be found with the help of burp suite or something kind. It's an so finally it's in final sent and then acknowledgement sent back. That's all. So this is how and TLS encryption and decryption of data occurs. It is just a simple example. This can be done for various amount of things. Kind of we know we have seen some site. Yeah. This lock symbol is nothing but for a secure connection. It is because of the TLS and SSL protocols running behind us. So this can be cracked or that can be decrypted by an ethical hacking, which can be used for study purpose. Unless until it's your own server or it's an own or a legally if you have rights to do this, you can't do the ethical hacking. So it's just an example of how we can do an TLS or SSL encryption and decryption. Thank you.